I want to welcome you to Autodesk University and my course, Create a 3D Model of Your City for Free. I'm Gordon Luckett. I'm a GIS CAD consultant, and you can find me at this site on LinkedIn. We're going to be using InfraWorks. And what is InfraWorks? Well, we're going to use it to create a neighborhood or city model. You could even make a model of just one single building. Now, what is this tool used for? Well, you can model your city using existing data. You can create brand new features such as buildings, bridges, things like that. You can analyze features, find the best route, or even look at the best way to put signs on a road. For example, you could see whether you can see over the verge of a road or around a corner of a road. Either way, you can have you can analyze and see those different roads. And as well, you can present to the web or capture a video. So InfraWorks does a lot. It's really great that way. Some of the spatial data you can use. Oh, you can use so much. And most of these are file-based. For example, you can use DWGs, both in 2D, 3D, as well as civil. MicroStation files, DGN. There's an import-export for InfraWorks, IMX format. Revit models can be brought in, so you can bring in the whole building and use those models, as well as the industry foundation classes found in Revit. CityGML and LandXML are both are accepted for sure. You can use either one. Point clouds. Now, this is really important for your digital elevation models. You can use LAS, LAZ, or Z, and also the recap files. So if you have recap and you create a model in there, you can use the RCP and the RCS from recap and bring those in. And that's really important when making your 3D model and looking at the surface of the earth. Some of the files that we'll be using will be shape files, and you could use SDF. That can come from Civil 3D or AutoCAD Map, as well as shape files from lots of other GIS files, or the SQLite files, also seen in AutoCAD Map in Civil 3D. As well, we'll be using a SketchUp file that we download, and we can use any of those files as well. So these are all the file-based data we can bring into InfraWorks. So there's a lot of types there, and they all can be used inside InfraWorks to create different features. There's other spatial data. For example, if you have a database with spatial data in it, like MySQL or SQL Server, and all you need is a geometry column or geography column, same with PostgreSQL or Oracle, if you have Oracle Spatial, so any of that data is spatial, all those databases can be used and rendered right inside of InfraWorks. So, but just a note here, all the files you use and all these databases you use are imported into your model. They don't get updated. So if you were to update your Oracle or your SQL Server database or even the file, InfraWorks will not see those changes until you manually refresh your model inside of InfraWorks. Just keep that in mind. That's one of those gotchas. Some people say, well, I updated Oracle and I'm not seeing it in InfraWorks. That's because you've got to requery the database again to bring it back into InfraWorks to see it. So that's one of those gotchas that you may miss if you don't know that InfraWorks caches everything. There's other data types you can use and types of data sources. The WFS, that's an open source or open data type called Web Feature Service. They're vectors and they can be brought into InfraWorks as well. Now, the background, this is interesting. One of the few background maps you can use is Bing Maps, and mostly use them for your aerials. So it's sort of a free service using Bing, and you can bring all that data into your model and have all the air photos. And you can make it as low res or high res as you like. That's the neat thing about Bing. And we're actually going to do that in this course as well. There's other generic OGR providers. That's generic, and they use OGR, which is a file-based open source or open type. In fact, you can bring in all sorts of types, like even an Esri file geodatabase, or all sorts of types that are supported by the OGR provider. So that's what generic means. So you can use all those sorts of types. But mostly, when we connect to a data source, we're talking about either a database or a feature service like WFS or Bing. Let's continue. Spatial data. ArcGIS Portal or ArcGIS Online. Here's a third way of getting data. If you have access to ArcGIS Online, So you either have data there, or you just want to browse arcgis.com to find data, or your organization has a portal. Either the portal could be public or internal, because portals usually set up with ArcGIS Enterprise. You could use ArcGIS portal or ArcGIS Online to bring in any kind of spatial data into InfraWorks. All you have to do is window the area you're interested in and do a search, and you can look at your own content, your own group, your own organization, or what's publicly available. So that's the third way of bringing data in. You can use all the ArcGIS Online or ArcGIS portal to bring that data in. So there's lots of opportunity to bring in data. You could draw data from scratch. You don't have to import it from an existing GIS. You can draw brand new items. Like, there's two different types of roads. There's component roads and planning roads. Planning roads are very simple. They're the types of roads that are created when you use a road imported from GIS. Component road is very complex. It has things like embankments and all sorts of things like that. Barriers, railways, rights of way, structures like points, as well as very complex bridges with all the different structures that go into a bridge, tunnels, individual buildings, which we will be adding, and some generic objects. In terms of drainage, this is the only water sanitary sort of data we have. We only have drainage, so there's no water or sewer pipes, just drainage pipes for now in InfraWorks. So keep that in mind. But you can draw culverts and pipelines and pipeline connectors and things like that. From an environmental standpoint, you can bring in city furniture, and that's sort of code for all sorts of things. It could be a stop sign, a park bench. I've even seen a hot dog stand in city furniture. You could have linear decorations, points of interest. Now, the most generic is coverage. That means any area. So if you use a coverage, you can bring in any polygon and color it any way you want. It's the most generic polygon you could put in InfraWorks. You can have grading areas, rivers, so those are lines, as well as water areas, which are polygons. So if you bring in an area that has all the ponds and lakes of your city, you could use a water area. You can draw a row of trees, so we draw a line, or a stand of trees, a polygon. We can bring in parcels, polygons, as well as easements, again, polygons. And as well, we can toggle the suitability maps. So these are all the features that you can create from scratch. These aren't the ones you import from GIS, but you can create all these from scratch or add to the data you've brought in from GIS. So there's all sorts of ways to drawing data inside of InfraWorks. And those are all at your fingertips. Now, what is the easiest way to build a 3D model of your city? Well, the easy way is using Model Builder. It really is the easiest way. So let's open up InfraWorks and try this now. So here we are in InfraWorks. Let's go ahead and click on the Model Builder button. That's right here, Model Builder. And we'll click on that. And the very first thing we do is we choose the area. Look, I'm over here in Scotland right now. So it automatically zooms over to Scotland. But I'm more interested in Marin County. And in particular, I want the area around Autodesk in San Rafael. So that's what we're going to do now. We're going to zoom all the way out, pan over to California, zoom right in to Marin County, and we're going to zoom into the area around San Rafael. There we are. Now, you notice at the bottom of the screen, it says selected area is too large. Please select an area less than 200 square kilometers. That's because the edges of my screen right now cover more than 200 square kilometers. That's sort of the limit at which I can build a free city using Model Builder. So I have to zoom in a little bit to do that. So let's zoom in. Oh, notice it disappeared when I zoomed into San Rafael. Now, if I zoom out, it pops back again. See that? It says 200 square kilometers. I have to do that. Now, I can draw a box. Oh, let me just grab the edge here and I'll move it over. And you can see it says 16 square kilometers. No problem. Make it a little bigger. 50, still no problem. 97. Not an issue. Let's zoom out, make this a little bit bigger till we see where it complains. It's starting to complain now. Here we are. So with that box is a little too big. So that's drawing a polygon. That's the second button. Now there's a third button we could use, and that's draw a polygon. So let's draw a random polygon around San Rafael. Draw it over here. You can see it's not complaining yet. And now it is. You can see the red area says 300 square kilometers, and there's the complaint at the bottom. So if I grab these little grips here and move it around, you can see I can make my polygon a little bit bigger. It's getting smaller, almost to the limit. There we go. We're under 200 and it's not complaining anymore. So that's really good. I've got the ability to do that. Let's look at the last way. So we saw the full screen, draw a box, draw a polygon. Let's import a polygon. Now to do this, I downloaded from the Marin County, the city limit shapefile. So let's just pick on the shapefile and pick open because that's what it wants. So if you're going to use a polygon, it has to be a shape in this case. That's what it's looking for. Now watch what happens when I pick it. Oh, it says select the shape in its corresponding PRJ file. A PRJ is the projection. It doesn't know what projection that shapefile is in. So you need to select both the shape and the PRJ. So let's do that. So that means I'm going to pick on that again, import a polygon. This time I'll use my shift key and select both the city limits and the PRJ. So both the PRJ, city limits, and the shape. So you notice in this where it says file name, I have city limits.prj and city limits.shp. Okay, good. Now I can get the outline of the city. There it is. Now it complained a little bit. It says we've converted multi-ringed polygons to individual polygons. What does that mean? Well, you can get polygons that have holes in them or islands. So for example, right there where it says country club, that's actually cut out of San Rafael. It's not managed by the city at all. So it's cut out. So for the area of our model, we want the whole thing. So what it's doing, it's converting it to an individual polygon instead. So that yellow polygon you see right there, that big yellow polygon, that actually is the polygon we'll be using. So we're going to do that. All right, let's do that. And yeah, we've converted to polygons, so we're going to have to use that. So let's go ahead and pick on it. Yeah, there we go. It's not selected yet, but we're going to go ahead and type the name. So I'll just call it San Rafael. You can put spaces in here. That's fine. And for the description, I'm going to say city of San Rafael. Now, this doesn't matter. It's not required, but it's just nice to have a description. And the next thing I'm going to do is pick the coordinate system. Now, I like to use generic coordinate systems like lat long, like it says, if unsure, select LLE4. But in this case, I'm going to use spherical Mercator or pseudo Mercator. This is the Google or Bing coordinate system. This is the web coordinate system that most websites use. So both the Esri ArcGIS Online likes to use this one. Google likes to use this one. Bing uses this one. So I'm going to choose this for now. We could use lat long. That's fine too. But in this case, I'm going to try using the WGS 84. And that's in meters, so it's easier to measure. So let's go ahead and choose that one. Click OK. And we can't create a model yet. We got the right coordinate system. We've got the name. Everything looks fine. But guess what we have to do? We actually have to pick the polygon so we can see the grips. There they are. Now I can click Create Model. So let's look at the details. Yep, San Rafael, coordinate system. Let's hit Continue. Oh, it says Select the tool. So what basically it's doing, we're done. We're done creating the model. It's gone off to the cloud to create. And what will happen, I'll get an email. So I'm going to wait for my email. And once it appears, I'll go back and close this dialog box. Oh, it just showed up. And there it is. So what happened was I just got an email in the background. My phone just binged. It said, I've got an email. That means that model's been created. And now I can actually pick it in the list. And it just shows up right here in InfraWorks. Now I have two choices how to open it. Do I open it and store it in the Autodesk Docs, so in the cloud, in the Autodesk cloud, or do I want it local on my own hard drive? I'm going to choose my own hard drive now. So let's go ahead and do that. So it'll download all the files, and it's a lot of data because it covers a lot of area. So it's bringing down, and we'll dig right in and see what it downloaded. But here it comes, point clouds, everything. We'll open the model. And there it is. So what happens is it caches all the tiles initially. So as you tilt it, it starts loading them really quickly. And you can see the outline of all the data that we downloaded. And you can see it actually clipped that polygon that was San Rafael. So we've done that. It's been clipped. And as we zoom in, you will see those tiles start to fill in as we zoom and pan. Yeah, see, those tiles are all filling in and they should be all loaded now. There we go. So let's just zoom in to where the headquarters are in San Rafael of Autodesk. And it's that building right here in the middle. There it is. If we pick on it, yeah, there's the building. There's the style it's been used. You see the roof height, it's 12 meters, so on. Oh, look at that. When I hover over it, there's a tooltip. And that's the neat thing about InfraWorks. You can put tooltips on all your data. And this one has a tooltip automatically added. The reason it's there is because when this was generated, it was the data that those building footprints were downloaded from OpenStreetMap. That's a publicly crowdsourced data set for GIS where data is stored that everyone can use. So let's pick on that link and see what happens. Look at that. It actually opens it up in openstreetmap.org. Again, that's a crowdsourced. You can upload and fix any data you want. You could upload your own buildings, your own roads, and give them the elevations, and it becomes a publicly crowdsourced place that you can get all your data. And many sites use OpenStreetMap because you don't need to pay. It's free. And it's available, and it could be as accurate as you want it to be. If you want to update this data, you're welcome to. So that's the wonderful thing about OpenStreetMap. And look, it's even got all the data. It's got the address, 111 McInnes, and it's Autodesk, and we'll just close that up. So there's Autodesk's headquarters right there in San Rafael. And it also downloaded other things. Look, there's a creek, there's a railroad. You can dip underneath, no utilities, just the main roads, railroad, things like that, and the various other things. So there's buildings in here. So we can look at some of the data. So what came across? There's the buildings. It imported different vector files. So it brought in vector land use, ground imagery. Now, if we look at this imagery, look at the data set or the connection string. It says dynamic equals Bing WMS. That means it's actually going off to Bing and importing the imagery in the background. That's what those images are on the map. That's Bing, and it's coming from a WMS service. So that's really good. So basically, Autodesk is giving you free access to Bing to put inside of your models, which is a great way to do this. See what else we have. We've got this Bing WMS. We've got railways imported. You can see it brought in a railway shapefile. Roads, it brought in a road shapefile. Again, we don't have access to the raw shapefile. That road shapefile is downloaded temporarily and then imported into our model. So our model has this spatial data, but we don't actually have the shapefile. So what other data we have? We've got TIFF files with all the different terrain, as well as we have the water areas, all those ponds and rivers and creeks and things like that. And we have all the different areas as well as the line work, like the creek you saw. So we have both the water polygons and the water lines, and they all came through. So look at that. So it gave us all this data from buildings, coverage areas such as land use, ground imagery from Bing, railways, roads, elevation terrain, as well as water areas. It brought all that together into the model. Now, it didn't bring in other content like street furniture or culverts or advanced bridges or more advanced roads. It just brought in the basics, but it's a great way to get a free 3D GIS of your city almost immediately. Look how fast that was. It's really quick. And we can alter it any way we want. So if I zoom and pan around here, you can see that there's other buildings and they've been styled automatically. I pan around and here's a building. So let's pick on this one building on the corner here and change it. So that one there, it's got its own facade. So what's happened is it still has the outline of the building, and they've just applied a brick facade to it and gave it a roof material and gave it even a roof slope of 15 degrees. It just all went in automatically. Unless OpenStreetMap had some of that data, it would apply it. But we can completely override what this is with a model that comes with InfraWorks. So there's a whole bunch of free models in here in our style palette. So we have barriers and facades and things like that. And we've got pipelines and that sort of thing. But under our 3D models, we've actually got residential. And it comes with about 7 or 8 different built-in types, and you can bring your own. These are all objects. You can bring them in from Revit, or if you've got a Collada file, whatever, you can import them and use them at any time you want. But these are the ones that come with InfraWorks, and you can use that. So let's just grab a 2-story building, drag and drop the style, and drop it on that one building we highlighted. And look at that. We've got a 2-story building automatically popped there and rotated. let's just pick the road so you can see it. So there it is. We've got a building that I just dragged and dropped over top the original footprint. Now, here's the interesting thing. The footprint has a shape. It's a polygon. But when you drag and drop this model, it just takes the center or centroid of that polygon that was the building footprint and pops that model right in the middle. And then you can pick on it, rotate it, whatever you want. But it doesn't actually matter that the footprint was, it could have been a circle, it doesn't matter, or a star shape. It's just going to take the centroid, insert this model, bang, right in the middle. And that's what it did. So now we've got a model with a brand new building. And you can see we've got all this data that represents most of San Rafael. And there we go. So that was the easy way. That was the easy way to create a 3D model in InfraWorks using the model builder. What's the hard way? Well, the hard way isn't that hard. It's just a harder way, I should say. So let's look at the harder way, okay? Well, you need data. So either draw it all yourself or go on the hunt for GIS data that's out there in the world. Well, the nice thing is Marin County actually has a GeoHub. It's an Esri GeoHub, and you can go there and download all sorts of open source data or open data that you're allowed to use. And what I did do is I went to this GIS opendata.marincounty.org, and you can do it too. Everything I'm doing in this class, you can do with me. You can go and download these files and find them just like I did. You could search the map data and go ahead and look in there, and that's the URL at the top of the screen if you want to try it. So let's keep looking here. So I only downloaded 4 files from this site. I got the building footprints. Now remember, with SHP files, these are the shape files. They're an Esri shape. It's kind of an old format because all the spatial data are, or actually all the spatial data is in it, but all the attribute data, so all the information that look like Excel, that sort of thing, is stored in a DBF file. DBF files, you actually can open them in Excel if you want to. I wouldn't recommend it because you could damage the shapefile, but to view them, you can. But anyway, we've got a PRJ, which tells us the projection. We have a DBF, which has all the attribute information, and an SHX, which is the index to make it nice and fast. So a shapefile, when someone says, did you give me the shapefile? It's not just one file, and it's not related to the shape that you use in AutoCAD. It's not. It's completely different. A footprint, building footprint shape has the associated PRJ, DBF, SHX, and so does the other files I downloaded from the site, from the marincounty.org. I got the city limits.shape and their associated files. I got the roads.shape and their associated files, and also the water bodies. I didn't get any rivers, I just got the water bodies. So I got some of the basics to recreate what we did using the model builder, but we're going to do it from scratch, the hard way. Okay, let's try that. So I also need elevations. I could use LiDAR. I can use a digital elevation model. I can get a TIFF file with all the elevations, also known as a GeoTIFF. And I did. I actually got a very basic digital elevation model for California. And it's only 30 meter pixels. That means it's really big. You know, that's 100-foot squares. So it really blurs and makes everything pretty smooth and not very steep. But it's small and it's really good for a demonstration. Now, I did download this file, and I stored it as a Stanford San Rafael GeoTIFF. So I downloaded from Stanford through their Earthworks site, and I managed to get this one GeoTIFF, and it works great. But it's 30 meters. But thank you, Stanford, for offering up this data for us to use. That's really great. So another place is their local universities and colleges. They do offer some data, as well as the county and city government. So that's really good. There's more. Speaking of government, if I want even more data, and in fact, I can even get down to the 1 meter, so 3 feet pixels. So that gives me a much better granularity for my 3D. So, and it is free. You can go to US Geological Survey and download it here at the apps.nationalmap.gov. I didn't use this in this particular demo because the data sets are quite large and it takes a long time to process. And I wanted to show you it using that 30 meter one because they're small and real quick to draw. Whereas here, you can wait quite a while, but you get really good resolution. And this is really, again, this is free. So this is free data. Like I said, it's the hard way. It doesn't come through the model builder, but here we go. We can just download these TIFFs and add them to our model. So now that I've downloaded all this data, Let's see how we can put it all together. Now, I'm not going to open up that CenterFL model because I already created it. We're going to create a brand new one, again, the hard way, from scratch. So let's go ahead and try that. So the first thing I'm going to do is I'm going to put new, brand new one, and I'm going to just call it Marin. There we go. And I'll just call it Marin County. And it's just a map. So we'll do that. Now, where are we going to store it? We're going to store it locally under my users, under my documents. So, and I happen to use OneDrive, so it'll put it there. Now, the coordinate system I'm going to choose, I'm just going to use lat long, just plain old lat long instead of using that spherical Mercator. I find it's easier. Sometimes it's a little bit tricky with InfraWorks if you're going to be using a shape file to get the extents, especially for when you're building a brand new model from scratch. That I find I have the best luck just using lat long in this case from scratch. So just keep that in mind. So the model extents, let's load the extents, and we're going to grab that same file, that AU file. Let's just open that up. Data. Okay, here we are. The city limits. We're going to use those same city limits to get the extent, and we'll use the first polygon. Oh no, we'll use all of them. There's actually 3 in there, wasn't there? So we'll use all of them. And that way we'll get the extents of the city limit. So we're going to create an empty model with nothing in it. It's just going to be a gray, empty box with no data, but at least we've got the extents of the model. So let's go ahead and see what happens here. And if you create it already, it'll just replace it. That's fine. And off it goes, and it creates a brand new model. Now it may take a minute, but there's no data in this. Zero data. It's a big blank space. There's no earth. There's no sky. It's just a square polygon. So let's close the data sources and start again. So what we're going to do is we're going to go into the content, go to data sources. Now this is, those shape files we just had, we're going to add them. Now I'm going to add them manually. You can drag them and drop them actually in as well. But I like doing it this way so step by step how the data is being added. So let's go new, and we're going to go down to shapefile and browse to the shapefiles right here under AU. That's my data set. And the first thing I'm going to add is the building footprints. That is the best thing to add, is the building footprints, because it really pops. We'll have a 3D city. Now, let me just jump back to that for a second where I just was. All right, we created this. I just jumped out of my spot. There we go. And we'll go back to the city. There we go. We grab the building footprints. Okay, we'll continue from there. Let's continue. Right, so we grab the building footprints and off they go. Now they're not configured. This is what I wanted to show you. The building footprint shapefile is added to my map, but it doesn't show up at all. The reason it doesn't show up is because it doesn't know what it is. Every single thing you add to InfraWorks needs to be flagged with what it is. It doesn't know it's a building. It's just data hanging out there. It's not on the map. It won't show up on the map till you tell it what it is. And how do we do that? We double click on it and change the type. See the yield symbol, the little triangle with the exclamation mark? That's a yield symbol. That means it needs to be assigned. So here are the options. Are they barriers, buildings, city furniture, all the way down to watersheds? We need to choose. Guess what? These are buildings, so we're going to pick buildings in this case. So let's go ahead and pick buildings. And there they are. Now, the default roof height is 10 meters in this case. If you have a column in the DBF, in the shapefile that has roof heights, I could have used that column right here, but we don't, unfortunately. So I'm going to make them all default at 10 meters. It's unfortunate. Be nice to get data from the county that has the roof heights in it, but unfortunately I don't have it. So I'm going to leave it at 10 meters. Same with roof slope. If I had a column in there, but what I do have is all sorts of building types. So what I can do is I can actually put the building type as a description. So the reason I do this is when you bring a shapefile or any other kind of vector file into InfraWorks, all the attribute data that's in the DBF or the database for that matter does not come across for the ride. What you have to do is match a column in the file with some attribute of the building, for example. So for example, now the description, which is permanently part of the buildings, is going to be the building type. And the name of the building will be building NA, building name. So I'm taking the building type and the building name and making that the description and the name, because the name and the description are permanent parts of the building model. So that's the metadata of the buildings. So if you want the attributes to come across, you have to match them up to something that already exists in the buildings, or you won't get those DBF information. So that's how that works. So at least I got the building name and the building type as name and description. And that's how I did that. So let's go ahead and set the coordinate system. Oh, no, it's already set. It's California, state plane, zone 3 feet. Perfect. Okay. Here we go. And we'll close and refresh. And what that does is it imports the entire shapefile in and starts to render all those different buildings. Remember, it's assigning the description and the type to each individual object. So it doesn't know what kind they are. It just knows that they're polygons. So if we zoom in now and look at them, you can see there they are. Now they're all 10 meters because we don't know what the heights are, but that's fine. We got 10 meters. We can change them any way we want. And there they all are. So we've got all these 10-meter buildings, and now we can add more data. So let's go ahead and add more. So under the dropdown, we'll pick shape. Let's go ahead. And in this case, we're going to bring in the water bodies. So we'll bring in the water bodies, and the process is the same. It's not configured. They don't know they're water bodies. It just knows there's a shape attached to our current model. It's not being used. It's not configured. The status is not configured right there. So we have to double click and change that type. Remember, we picked the type where it shows that yield sign. This time, they're going to be water areas because they're polygons. It's a shapefile of areas that show all the water. Now we can change the name again. Here's all the different types. So we could put all sorts of things in here. So we can just randomly pick what you'd like. In this case, I'm going to put the type of water it is in the name. Now it could be, I could put actual name in there. So, you know, look at the coordinate system. That's fine. And we'll hit close and refresh. And then all the water bodies will appear. And there they are. So we've got all the water bodies, all the ponds and creeks and that sort of thing. Well, not the creeks because they're linear, just the polygons. So just most of the ponds and retention ponds and things like that. And there we go. So let's add the next thing. So we're slowly building up our city. Remember, this is the hard way. So let's bring in the roads this time. So we'll bring in the roads. Not configured. Same as the other two. Guess what? It's brought in, but not configured. So guess what we have to do? We have to go in and say they're roads under the type. So here's the dropdown of built-in things. We have culverts, we've got railways, rights of ways, all these sorts of things. Guess what these are? They're roads. So we're going to pick the roads in the dropdown box. There they are. And maybe we could put the road name as the road in the description and so on. So in here, we're going to pick whatever the road name is. So yeah, local road name as the name, that works. We can override the style if we want to. We can use a column in the database, or we can make a rule to pick what style we want. Okay, let's close and refresh. And the single line roads will come across. Now we can alter them at any time just by pick on the roads that we want. Now, if we pick on either roads, we can see if there's any data. So these little smaller roads, if we pick on them, you can see that there's no name attached. There's no name to this one either. But you can see there's the single line road network. So now we have roads, we have buildings, we have water bodies. We're coming along quite nicely here. So what else can we add? Another shapefile. This time, we may want to bring in the city limits. So just the area that's the city limits. So this will be the outline of San Rafael. So let's go ahead and bring that. Oh, guess what? We have to change the type. Now, there's no city limits type. So all the other things, we had water bodies, we had roads, we had all sorts of things like that. We had buildings, but there's no city limits. So we have to use something generic. In this case, we're going to use coverage areas. Coverage areas are generic polygons. So if you have a polygon, use coverage areas. So let's go ahead and use that. We'll close and refresh and check that out. And it should show up sort of a darker or lighter color. And you can see it in the background, sort of when you hover over it, you can see the polygon that is San Rafael proper. You see when it's highlighted. Now I could pick on it and manually change the style. So there's all the grips. You can see it. And you see the manual style in the pane right there. I can just go in here and pick a particular style. And in coverage styles, there's restricted, there's terrain. There's all sorts of, I can create my own, but in this case, I'm just going to pick grass just for fun. I'm going to make the whole of the city of San Rafael green grass. So if we zoom in and we deselect it, you'll see it rendered. There's a green grass color. That's basically Centerfell's all green grass now. Yeah, so there we are. So far we've got buildings, city limits, roads, and water bodies. What else can we add? We're going to add the raster. So we're going to bring in the geotiff. Now this is the 30 meter pixels. So we want to bring in elevations to give, because right now our whole model's just flat as anything. It's so flat, you can see your dog run away for 3 days. Like it's really flat. We need some terrain here. So let's do that. So we're going to bring in the geotiff. And even though there's 30 meter pixels, we can still get some kind of contours. It won't be as dramatic. So we have to go in, and it is a raster file. There it is. And we can see that it should be not ground imagery. It's not imagery at all. This geotiff is actually terrain. So we're going to bring in terrain. So that's better. So you can make sure if you're going to bring in a geotiff or something with elevations, you make sure the type is terrain. Because if you just have an image, that's fine, but it's probably an air photo. If you're using terrain, that's a digital elevation model or LiDAR. Okay, so there we go. It's lat long. And now it's really subtle. If you look around some of the ponds, you can see little divots in our model, and you can see just little bumps in our landscape. It's very subtle because the pixels are so big, you're not getting the elevations that we normally would see, because it is quite hilly around that part of Marin. And you can see in the horizon, there's a bit of hills, but it's really reduced because they're all generalized to 30 meters. So, but you can see a little bit around the road. You can see here, there's little dimples and so on. So there is elevation in this model. So now that we've got elevation or terrain, we've got road, we've got city limits, we've got building footprints, and so on. What's the last thing? Guess what? We're going to bring in Bing Maps, aerial photos. Now here's the trick with Bing. It's imagery, but we've got all sorts of resolution. The lowest resolution is just really fuzzy at this scale. It's 1. And the highest resolution is 19. Now, I'm not going to use 19 right now because it would take about a half an hour to render for the city of Centerfell, because it's about a half an hour. It's a lot of data with this computer. It's worth doing because it looks fantastic. It's worth waiting the half hour for, trust me. But we're not going to do it just now. We're going to do it a lot lower. So, around 15 or something. Oh, 13. Yeah, we're going to do 13. That's a good size. It still takes about 2 or 3 minutes to render. So let's go in there. Now, it's not configured. There's something we got to do. Now, it's ground imagery. That's fine. That's correct. But you know what it is? It also needs to be classified. So we can use topographic map, a satellite, aerial. In this case, we're going to pick on aerial because that's the type of data we have. And that will come through, and you'll see the aerial render from Bing. So it's downloaded all the imagery from Bing, and there it is in our background. And now you can see it. And there's the Bing image. And the tiles come in slowly from Bing. Now, this is pretty quick because we're only using that level 13 imagery. But as you zoom in, it gets pretty fuzzy because we've only got the low res data, the level 13. So zoomed out, it's okay. But as you zoom in, you can see, look how fuzzy it is, right? Super fuzzy. So there's Autodesk again. We can also change the building. So let's go in and actually enter a name because we manually added this. So there's Autodesk. Let's make the building Autodesk Inc. There we go. And now we've got it going. So not only have we added all the data, we've actually modified one of the buildings to say Autodesk. So that's perfect. We got that going. So that's the hard way. We still have to go and style all our buildings. We still have to style all our roads and things like that. So it looks more like a model because a lot of that was done for us using the model builder. But at least we're getting there. And the nice thing is by downloading that data, we've got beyond the 200 square kilometer limit, because when you do it yourself, you're not limited to the limit. We can go as big or as small as you want. So that's the nice thing there. So let's move on to the next part. Let's look at style rules. Let's look at style rules, not styles. Styles, you can adjust individual buildings, for example. But with style rules, you can globally change a whole bunch of buildings or a whole bunch of roads based on a particular attribute value, like the description or the name. And that's pretty powerful stuff. So let's look at how to do that. Well, first of all, I had to dig down into the building types that Marin gave me. So here's the buildings on their portal. I said, okay, well, here's the building footprints. How do I know what the building types are? Well, the building type says general, but when I looked at it in the shapefile, I got the number 1 and number 2, number 3. I had no idea what this meant. So I went to the portal and said, so 1, maybe that means general, but I'm not sure. The nice thing is, if you go to the GeoService, that's the second button right here, and you click on it, you are able to see what the real data is. So let's go to the next slide here. So I drilled down a little bit and realized, general residential, the code is 1 for the building type. And you can see there, industrial is 12, the community center is 13, government buildings are 2. So now that I've got this data from the Marin County, I know that if I style everything that's residential with 1, I can globally change everything in InfraWorks to use that residential style. So let's try that. Now let's try to use styles to change the style of each of the buildings. So if you go into the style rules, we need to make sure we're in the style rule area. So let's just call this residential, big R. We'll put in residential, and in there, we'll do a rule that says if the building type is residential, but wait a minute, how do we get the building type? We don't have it. So let's go back into the data content. So we'll go into the content, we'll go into the data sources and look at the building footprint. And in there, we got to make sure that the description is building type. And that's coming from the shapefile. So the building type is description, perfect. So now we'll use the description to drive the style rule. So we'll go into the expression and say, let's go to one of the common features, which is description. We'll pick that. And if it equals 1, it's residential. So we'll just pick on the description again and give me all the ones. And you can see it goes from 1 to 13, and 1 is residential. So we'll choose that and we'll go ahead and do that. And then we can add a style, and we'll go into we're not going to change the material. We're actually going to go in the buildings. We'll go into residential, pick a 2-story building, and maybe we'll pick this one here. Yeah, the last one. And then we'll pick OK, and then we'll hit OK. And then if we run the rules, it'll render all the buildings a particular style. So basically everything that is residential will show up as this 2-story building. And that's all we've got right there. We've got 2-story buildings based on that rule. Now we can continue through all the rules, make a industrial one, a residential different, and so on. But that's up to you. But right now we're just going to stick with description equals 1 and move on. Okay, let's keep going here. And next, we're going to talk about importing SketchUp models. Now, SketchUp is just another type of model that we can add. We can add all sorts of things. We could get Revit models and things like that. But in this case, I found a free site that I can use called 3D Warehouse. And I found this model online. I just searched for models and I found Lars Homestead. And those are familiar. This is actually the house that Luke Skywalker grew up in. And actually it exists in real life in Tunisia, but we're going to insert it and put it right next to Autodesk headquarters. So let's do that. So I've downloaded this SketchUp model, and we're going to go inside of our model and put right beside Autodesk headquarters. We're going to put that SketchUp model in there. We're going to go ahead and import, and we choose SketchUp inside here. There we go. Browse, and we'll pick on Igloo, hit open, and we'll send it, and the cloud will process it. The Autodesk cloud will process that SketchUp into a model that we can use. And got to make sure it's a building. Yes, that's one thing. And then we're going to use interactive placing and just put it where we want. And you can see there's a tiny little version of it being inserted, and we'll put it right there on the corner of the property, and we'll leave it, close and refresh, and it will render the homestead, Luke Skywalker's homestead. So first of all, let's rotate it slightly so it looks good on the property. So when you pull in and make it slightly bigger, and there we have it. We've actually downloaded a model from the 3D Warehouse, free, because that's the whole point of this process, is to build a free city with Luke Skywalker's house right there next to Autodesk headquarters. So let's look at the summary. What did we do? Well, the easiest thing to do to build a 3D model of your city is use Model Builder. It gets most of the data from OpenStreetMap and Bing and downloads and creates this really great, real quick way of getting your city. Now, the hard way was find all your own free data. And what we did was we used county and government sites such as the Marin GIS Open Data Portal or USGS and brought all that data. Then we import data into InfraWorks, and you can put your own in as well. We use style rules, and you can also use just regular styles to alter many features, as well as you could import individual models from free sites like we did with the 3D warehouse. So you can bring in Luke Skywalker's home if you want to. So these are all the very quick ways to get a 3D model of your city for free inside of InfraWorks. I want to thank you for attending, and I hope you enjoyed this course as much as I did teaching it. Have a great AU.